Hello, my name is Philip Plantz, and today I'm going to teach you about sets. So, a set is a collection of well-defined and distinct objects. Or in other terms, it's just a group of items. Now, each and every one of these items are called elements. And the elements are what makes up a set. Now, elements can be anything, and that set can be a collection of anything. So, let's think about Pokemon cards. Here we have a set of Pokemon cards. In card games, one set is considered your hand. In Pokemon, your hand is considered 7 Pokemon cards. Now we have 2 sets, which each contain 7 elements, or 7 Pokemon cards. In mathematics, sets usually contain elements of numbers. A special type of set would be Z, which is the collection of all integers in existence. Z is also special because it's an infinite set. That is, it contains an infinite amount of elements. Let's look at -1. It is within Z because it is an integer. 100 is also in Z because it is an integer. But 1.5 is not an integer and therefore is not in Z. Sometimes you'll have a problem that deals with multiple sets. Sports is a good example of something that we can use more than one set in. Here we have a table of wins and losses from various teams from 2009 to 2010 season and 2010 to 2011 season of hockey. We can create multiple sets using this data, but today we're going to make 2 sets, A and B. Set A is going to contain every team that won more than lost games in the 2009 and 2010 season, while Set B is going to contain every team that won more games than lost in 2010 to 2011. Here, I highlighted the various teams who won more than lost them in the various seasons. As you can see, yellow is highlighting the teams that won more than lost in 2009-2010, while light blue highlights 2010 to 2011. In other words, the teams whose scores are highlighted yellow are in Set A, while the teams whose scores are highlighted light blue are in Set B. I have listed the 2 sets. Set A contains 2 elements, while Set B contains 3 elements. As you can see, I also included a third set. This is S. It's going to be our sample space, which basically contains every single team we looked at. The catch. Okay, sometimes you're going to have to create a set out of these 2 sets. To do that, we have multiple set operations. Here we have the union. We have the intersection. We have the complement, and we also have the set difference. We can use these set operations for hockey teams to create a number of new sets. The first set is A intersect B. A intersect B contains every element that is in A and B. The Air Force was the only element in it because the Air Force was the only team to have more wins and losses in both seasons. The following set, A union B, contains every element that is in A or B. A set only lists an element once, so Air Force is only listed once. The set difference of A and B is every element that is in A, but is not in B. Similarly, the set difference of B and A is every element in B, but not in A. Therefore, the Air Force is not mentioned, because it is also in set A. The final notation is the complement of B. This set contains every element that is in the sample space, but not in B. Well, I hope you liked this video and learned a lot. This has been me, Philip Plantz. It is I, Dr. Assessment. Dr. Assessment, my evil but good-looking nemesis. I couldn't help but notice that you were going to end the video without some form of assessment at the end of it. Now I couldn't have that, so I have brought along with me an assessment of sets.
Before you lice 2 sets, answer my questions, because if you don't, I will destroy the world.
You fiend, you!
Yes, I am. The 3 questions you have is A intercept B, A union B, and B minus A. If you can answer these 3 questions, I will not destroy the world. How about that?
I didn't believe you'd be so so evil. Please, do this assessment. The fate of the world rests in your hands.